We now write the polynomial p of x in descending order form, whose zeros are given as -4, 8, 5, and -3, and the y-intercept is given as 4. So let me write the polynomial p of x, and this equals, I put the multiplier a, and this has to be multiplied with the linear factors for each of the zero. So for the first zero, -4, I put this linear factor x minus of -4, and for the next zero 8, I put this linear factor x minus 8, and similarly for the other zeros 5 and 3, I put x minus 5 and x minus of -3 for the last zero -3. And here we have to determine the value of a. So first let's simplify this p of x. We have p of x equals a times of, this is minus of -4 is plus 4, so we get x plus 4, and then we have the factor x minus 8, and then the next linear factor is x minus 5, and finally we have this x minus -3 is x plus 3. So this is the polynomial p of x. To determine the value of a, we will utilize this information, that is y-intercept equals 4. That is when x equals 0, y equals 4. Otherwise, this y represents the polynomial notation, that is p of x. So we have to put x equal to 0 and p of x equal to 4 into this polynomial function. So when we do that, we get 4 equals a times of, replace x by 0, so it becomes 0 plus 4 times 0 minus 8 times 0 minus 5 times 0 plus 3. Let's simplify and determine the value of a. So we get 4 equals 8 times of 0 plus 4 is 4, and 0 minus 8 is -8, 0 minus 5 is -5, and 0 plus 3 is 3. And so this gives, we can divide both sides by 4 now. So I divide by 4 and also divide by 4. So we see that this 4 and this 4 gets cancelled, and also this 4 and this 4 gets cancelled. This goes one times. So we now have 1 equals a times of -8 times -5 times +3. And so this gives, we have 1 on the left side. This equals -8 times -5 is +40. 40 times 3 is 120. And then 120 times a is, we can write as 120a. Now divide both sides by 120 to determine the value of a. So therefore we get a equals 1 over 120. So we determine the value of a, which means we can substitute into the polynomial function p of x, that is into this equation. So let's replace the value of a equals 120 here. I'm going to put 120. I'm sorry, this is 1 over 120. So this is how the polynomial looks like, but we have to give the polynomial in a descending order form, and this means we have to multiply all these terms so that we get in terms of descending order form. So let's do that. Let me clear this for some space. Okay, so first I put this 1 over 120. This is a constant. We will keep this, and I'm going to multiply these two terms first. It is a little bit easy than multiplying other two terms. So I am going to multiply these two terms first. So I write down that these two terms are multiplied first, and then the next two terms are multiplied. That is x minus 5 multiplied with x minus 8. We can multiply in any order, it doesn't matter. So let's do that. So we have p of x, and this equals 1 over 120. When you multiply these two terms, or if we FOIL this, we will get x squared plus we have this number 4 and 3. we have to add these two, that is sum of the terms. 4 plus 3 is 7, and then we write down that as 7x. And then we will also have to multiply these two, that is 4 times 3 is 12, so we put this as 12. So basically when we multiply these two linear factors, we will get a quadratic expression as like this, that is we will put x squared first, and then we have to put the sum of the numbers, put x, and then we will also have to put the last number as the product of the numbers, so which makes it easy to multiply. And similarly, when we go by that approach, I first put x squared, and then I have to put the sum of these two numbers, that is negative 5, negative 8 is negative 13. So I put this as negative 13 along with x, so it becomes negative 13x. And also put the product of these two numbers, that is negative 5 times negative 8 is positive 40. Sorry about it, plus 40, so I put 40 here. Now we have to multiply these two inside expression. This is quadratic and this is also quadratic, so let's do the multiplication. So I put p of x, and this equals, we have the factor 1 over 120. It's a constant multiplier, so we just keep it as it is. First consider the term x squared, and then multiply with all the terms in the second bracket. So x squared times x squared is x raised to the power of 4, and x squared times negative 13x is negative 13x cubed, and then x squared times 40 is 40x squared. I'm done with multiplying x squared with all the terms in the second bracket. Now I consider the 7x term, and then I multiply the 7x term with all the three terms in the second bracket. So 7x squared times, 7x times x squared is positive 7x cube. So I'm going to put down below this x cube term, so that later on when we add it, it will be easier for us to add these like terms. And then now multiply 7x with negative 13x. When we multiply the numbers 7 times negative 13, we get negative 91, and then x times x is x squared. So I put this under the x squared term, that is negative 91 x squared. Now when we multiply 7x with 40, we get 7 times 40 is 280, so we get 280x. Now we are done with multiplying with 7x. Now we will take 12 and then multiply this 12 with all the three terms in the second bracket. So 12 times x squared is x 12x squared. So I'm going to put this below this x squared column. And then 12 times negative 13x, we have to multiply the 12 with the 13, and this equals 156. So it's going to be negative 156x. And then finally we have 12 multiplied with 40, and this equals 12 times 40 is 480. So this is what we have. And in the next step, we have to simplify this expression inside the bracket. So I put this x power 4, this is the only x power 4 term, and negative 13x cube plus 7x cube, and this gives negative 6x cube. And then we have to add the terms in this column, that is x squared column. So we have 40 minus 91 plus 12, and when we do this, we get negative 39x squared. Now when we add these terms in the x column, that is 280x minus 156x, we get positive 124x plus we have 480. So remember that this has to be multiplied with the multiplier 1 by 120, and this is p of x. We will now multiply this 120 with all the terms inside the brackets, so that we can write the p of x in descending form. So p of x equals 1 by 120 times x power 4. We write this as x power 4 divided by 120, and then we have to multiply this negative 6x cube with 1 by 120. So we will multiply the numbers as like this. When you multiply negative 6 with 1 by 120, we will get this. we can reduce that. This reduces to negative 1 by 20. So it's basically negative 1 by 20 x cube, which I can write this as negative x cube divided by 20. And we will now have to multiply 1 by 120 with negative 39x squared. So let's reduce that as negative 39 divided by 120. We have the common factor of 3. So this is 13 times 3, and 120 is 40 times 3. This means this 3 and this 3 will get cancelled. So we basically get negative 13 over 40. So this is the fraction, and this has to be multiplied with x squared. So we will get negative 13x squared over 40. And we also have to multiply this 1 by 120 with the next term 124 by 124x. And so when we do and simplify, we will get 31x over 30. And finally, we have to multiply this 1 by 120 with 480. It's equivalent to dividing 480 divided by 120, which gives 4. So this is the final expression for the polynomial p of x in descending form of x. We now evaluate the function at x equal to 8 as well as at x equal to 3. So first, let's determine the value of the function at x equal to 8. So it's basically finding p of 8. And if we observe that we already know that the function has a 0 at x equal to 8. So therefore, we can immediately say that p of 8 equals 0, because uh, the function is 0 at x equal to 8, and this means when you evaluate p of 8, it's going to be 0. So p of 8 equals 0. Now let's determine the value of the function at x equal to 3. That is, we have to find p of 3. So we find p of 3 by replacing x by 3 in the p of x function equation. So when we do that, we get replace the x by 3. We get 3 raised to the power of 4 divided by 120 minus 3 raised to the power of 3 divided by 20 minus 13 by 20. Sorry, this is 13 by 40 times x squared. So replace x by 3. So you get 3 squared plus 31 by 30 times x. So times 3 plus 4. Let's simplify and evaluate this. So we get p of 3, and this equals 3 power 4 is 81, and this is 81 over 120, minus 3 power 3 is 27. This is over 20, minus 13 times 3 square is 9. So 13 times 9, and this equals 117. So I'm going to put 117 here over 40, and then 31 times 3, and this equals 93, and this is over 30, plus we then have 4. So I'm going to put this as a fraction, that is 4 over 1. And now we see that the least common denominator of this fraction is basically 120. So let's simplify this fraction. I'm going to put this least common denominator, that is all over 120. And since in the first fraction we already have the denominator 120, so we don't have to multiply this 81. We just have to put this as it is, minus in the second fraction the denominator is 20, and this means compared with the least common denominator, this 120 goes into 20 as 6 times, and this means we have to multiply this number 27 with 6 times. So it is 27 times 6, and this equals 162. So I put negative 162 here. And when you look at the next fraction, the denominator is 40. So 120 goes into 40 as 3 times. And therefore, this 117 has to be multiplied with the 3. So let's do that. And when we multiply 117 with 3, we get 351. Since it is a negative number, I put negative 351. We then have plus the denominator in the next fraction is 30. So once again, we divide 120 by 30 and we get 4 times. And this means we have to multiply this 93 with 4. So 93 times 4 is 372. So I put 372. And when you look at the next fraction, we have the denominator 1. So 120 goes into 1 as 120 times. So therefore 4 has to be multiplied with 120. And this gives 480. And now we have this common denominator. And this means we can add the numerator terms. So when we add this 81, negative 62, negative 351, plus 372, plus 480, we get 420 in the numerator. And this has to be divided by the denominator 120. And this equals 3.5. So therefore, we see that the value of the function is 3.5 at x equal to 3.